And on that, we can get our day started. So today we are going to be talking about software quality for the enterprise in the age of DevOps. This question comes up for me quite often. I get questions about, how are we going to handle testing in microservices? What kinds of testing is out there? There are so many different ways of testing. There's functional testing, there's load balance testing, there's all kinds of different kinds of testing. So when I met Rosalind, and I heard that she had a new book out, I actually reached out to her shamelessly on LinkedIn and asked her to do a presentation. Rosalind is an IBM Distinguished Engineer in the area of DevOps, including testing. She has a strong background in testing. She recently published a book called Bug Busting: From Testing Through CI/CD to Deliver Business Results, which I think is a fabulous title. So she is going to be enlightening us today with everything that she has learned over the course of her career in the topic of testing. And I'm going to add one more person to the discussion. Hey, Amika, thank you for showing up. I know he has a background in testing as well, so maybe that will help stimulate some conversation in a proper meetup format. So on that, Rosalind, I am going to turn it over to you to get the ball rolling, and if you'd like to share your screen, you can go ahead and do so.
Thank you. Yeah, I want to talk about testing, though, saying all the testing through my 34 years in IBM. Maybe I'll skip some of all of what I've done in testing. But I think it is important to think about testing in today's world and what's going on in today's world, because with all of the DevOps transformation and with all of the things that have happened recently, it's really important to recognize that software quality is definitely more than testing. Software quality really is an enterprise level consideration. It's everything. It's part of the entire enterprise, and everyone has to play the appropriate part in that. We can't just test. We have to pay attention from software quality from the very beginning. And I am going to see if this wonderful system wants to behave today, and let me share correctly.
Looks great. You're good.
I think that shows, though it probably shows Slack in the background with a miserable set of things, but that's okay. When we think about software quality, we really have to think about this overall picture, and it really is everyone. And I used to use this picture to talk about user experience when I was early in my career, talking about user experience from the standpoint of what the user experience is not just on the glass, but it's everything underneath. And I thought, when thinking about it from a quality perspective, I think that's just as true. And that we really do have to think about this from the overall perspective. And when we think about it, and we think about what we've done in the DevOps transformation to try and break down the silos, to try and bring people together, when we talk about full stack engineers, we end up not necessarily focusing on the value that each individual might be able to bring, and focus on the fact that it would really be good to have full stack teams. We really need to get this team of people working together to deliver this value. And when we think about DevOps and it's automate everything, we want to automate as much as possible. So we want to have that DevOps pipeline. We want to have the pipeline for CI/CD to allow us to deliver what we want to deliver. And if we can automate all of those steps that no human really wants to do, like those manual repeatable tasks, then it makes it so that people can spend time on those key creative areas, such as writing the business function, or writing the automated tests, or writing the infrastructure code to make sure that you're delivering the value you want to. So I wanted interesting timing for the question. I want to stop right there and say, when we look at this list and metrics and all these places, what's the conversation? What are other people seeing? And I'm going to make one other comment. I actually just changed jobs, literally, like 2 days ago. And my new role, I'm responsible for DevSecOps for IBM internal. And so I've taken a new role rather than helping external clients, actually helping IBM. And one of the things I like best in talking to clients is hearing from others on what they were doing and what they saw. So comments, questions? You can unmute yourselves.
I'll just ask the question on your job transition, which I'm curious about. What do you think you're going to take? Well, first of all, where do you see IBM kind of on the continuum of software quality, maturity internally relative to external? And maybe it's not a fair question, but I'm curious, given it's a notable shift you're making from externally facing to internal.
So I have been responsible for building product in IBM as well. And so building our product capability as well as working with clients. And now I'm moving to our internal processes. IBM is a company as big as any other company. I think some areas of IBM's internal development process are ahead of other areas that I've seen in the industry, and some areas are not. That's the polite way of putting it. I think that's the best way of putting it. So I think we have everything. And I think IBM is representative of many large enterprises in the fact we have everything. We have this combination of things. We've gone through all of the phases that everyone else goes through. You were waterfall, and then you went agile, and you dispersed things, and you had all the teams doing what they wanted to do. And then, security matters a lot. And actually in IBM, security by design, security and privacy by design has mattered a lot for a long time. But how do you enforce that? How do you ensure that? And so that's one of the reasons we have the new role for me to come into to help drive this DevSecOps model across all the teams to help provide the right support for all the teams, give them the right flexibility so that they can deliver value, but also provide some centralized capability to make it simpler for them. It is a big change, though, at least for me. Other comments, questions? One of the things on this chart is metrics, and that's actually one of the things I like to talk about when I talk about software quality, and I like hearing stories from others. Metrics drive behavior, or metrics can drive behavior, and they drive whether or not you're going to end up producing quality. They can help you produce higher quality, or they can help cause bad behavior. And I've seen many times metrics used to help improve things, like I've got to have 100% code coverage in my unit testing, though I'm not sure that actually helps improve anything. It drives people to do things in interesting ways. So having the right metrics, understanding the right metrics that help improve quality is another item that I think is really key in this driving of software quality. I mean, the DORA metrics are a set of metrics that are very valuable, but then there are others that you may want to measure at a team level. You might want to help the teams understand where they're going. And 100% code coverage is probably one of the examples of one that I think has caused more trouble than value, but improving code coverage has been a positive in the metrics measurement.
Yeah, and I'll just comment, Rosalind, relative to what you said. I think it's interesting, metrics both from a what are you discovering and what's being identified as a result of testing activities? There's metrics also that extend externally to the users of an application, right? Whether that's an internal or external application, B2B, B2C, and it's finding, one of the things that we think about at Testlio is how to strike the right balance between those two things as we work with our clients. Is the balancing act between the internal metrics of how are you doing from a QA process perspective with externally the users of the app, and how do you take those inputs and those data points as well?
That feedback from a user on what they perceive of the system and how they can interact with the system, I think is one of the most important metrics actually in this. I can have zero defects, though. Okay, I can't actually have zero defects in code. That's not realistic. But if the users think the experience is lousy, it just doesn't matter.
Yep. We see that where folks make the false assumption that if you have internal metrics without a balancing act, and some of it is stakeholder driven, right? Which is certain parts of an organization will care more about the external metrics versus the internal ones. So thanks for confirming that.
Yeah, and I think it is a combination, because I do think there are a set of metrics that help you find problems sooner. You can't write perfect code. There is just no perfect code, but you can write better code, especially if you have the right tests associated with that to validate that you're actually doing what you intend. So I do think there are some metrics about improving unit testing or improving coverage or improving functional coverage or the areas that are business critical coverage, the key transactions. I do think those kind of metrics help you. But that last top bit of the pyramid that should be the smallest amount of testing, at least early testing, it really does have to be user-centric and user-driven. And it's the one place that it's manual. It really is the user experiencing. And I've worked in user interface design many times in my career. I'm sorry, the users are the ones that matter, not what I think they're going to like. It's what they think they like. Or what their experience is. And it needs to be, and it depends on the system. Some systems have to be simple and easy to use for children to grandparents. And some systems, have to be set up so that they're used by a particular class of user. There are applications that are designed for specific agents or specific environments, and they have a different kind of expectation of experience than the end user experience. So we also have to keep that in mind as we're building this. Who is it being built for, and how do we need to test it? The other thing about this picture that I've got here is this idea of testing as much as you can in isolation before you deploy or before you deploy into a real environment. Making sure that you're focused on having a set of tests that you can easily test as a developer, as part of the pipeline, as quickly as possible to get that fast feedback before you ever put it into an environment where it's connected to other systems. If you can get as much of the challenge out of that and completely automate it. I put a challenge, and I've put it in many organizations, to completely automate their testing other than that user acceptance testing. And then the one other area of manual testing that I find absolutely wonderful is actually malicious testing, i.e. Really trying to get those people who are really, really good at finding problems to actually go at it in a free form way and and try and break the system, or try and find an exposure from a security standpoint, or try to see that it just doesn't work the way that you need it to. That kind of malicious testing is the other thing that I think is very helpful from a manual standpoint. But if possible, everything else is automated. Now, a lot of people are not to that point, and I actually love to find somebody who is at that point.
So just a comment, Rosalind, the Continuous Delivery Foundation is reworking the CDF landscape. It's a great project because it's overdue since the pipeline is changing, and one of the areas is automated testing. So I think this pyramid gives there were some questions about how testing is kind of segmented in the different tools in the space. So I'm just, putting a little bug in your ear to say, hey, if it's something you'd like to participate in to help build out what that testing landscape looks like, we could use you.
One, I'm happy to help. Two, I think this is really important because there are lots of tools in this space addressing different parts of the space. And it's important to recognize which pieces are going to help you the most within your organization. And the other thing about this, I always have to be careful when I'm talking about testing. You can't test in quality. So testing is there to verify that you have what you expect. You have to have built quality from the beginning. I like unit early testing, allowing the developer to get as fast feedback because it helps them think. It helps them think about the problem. It helps them focus on the issue. And so by getting this early testing done, helping them make sure they're thinking about all the scenarios and reminding them it is by design, you're trying to design in quality. Have you put in the system enough for reliability characteristics? Have you put in enough from a logging standpoint or an understanding so that you actually can find the problem at 2 a.m.? I actually think one of the most fun changes in the new product aligned teams and getting rid of separate teams per se, but having the product teams, this idea of developers having to answer the page in the middle of the night, it changes the way you write code, no matter what anybody says. You don't write code the same way if you're going to be responsible for it, because you are going to want to have to, you don't want to have to get up at 2 a.m. and figure out what's wrong. So you put in more logging, you pay attention to more things. And that change in thought process is also really important for application developers so they understand the impact of what they're building.
That funny word, accountability, that has a great impact on behavior.
And it's not just accountability. I know teams have been accountable, but they didn't have to get up in the middle of the night. That twist has made, well, I know I don't want to get up in the middle of the night. Maybe that's why I don't write code anymore, but that's a different discussion. The other thing that I think is really important about this pyramid is the system performance, scalability testing. When I talk about testing and testing in the enterprise, one of the things that I think is really important and gets me into trouble every time I say it, so I'm going to say it, is you can't test in production. Okay, I haven't gotten in trouble yet. You can't test in production, i.e. you have to actually make sure the code works before you get it into production. You're not testing for defects in production. You're testing user experience through A/B testing or scenarios or things you want to know if it helps the user, marketing campaigns, those kinds of things, not the idea of I'm actually putting it out there to test. But the key piece of that is scalability and performance testing. Can you see the slides now?
I
Or
can
did they
see.
disappear?
I never
Yeah,
lost
they're
them.
visible.
So
Okay.
yeah,
Yeah, I
never
haven't
lost
lost
them.
them.
Robbie,
Okay.
are you okay? Okay, great.
Okay, I'm not sure. I moved
Yeah.
it a little, but okay. The idea of performance and scalability testing in an enterprise, there are a few comments that cause problems, things like fail fast and test in production. And the reason in some cases that happens is, especially I'm going to pick on financial institutions, you can't afford to be wrong. And more importantly, I don't want them to be wrong. My bank account balance shouldn't get screwed up. I shouldn't have two subtractions go through. I always joke, I wouldn't mind if you give me my paycheck twice, but somebody else is going to mind. So that can't happen. The point is, there are things you can't test in production. There are external scenarios that you can, but performance and scalability testing is one thing that many people seem to try and do in production. And that's what causes a lot of failures and problems. So the more you can figure out how to do that performance testing early on in the development effort, even long before the code is fully complete, even when you've just started it, making sure you can actually get some kind of performance or scalability testing. You get an understanding of how it's going to perform, so you know what you need to do with the application. Also understanding what are the qualities of service for an application. If I'm building an application that has to, maybe work, or it's acceptable if there's an error because it's a temporary problem, you come back and you refresh the screen and everything's fine and there's no issue, then that's one level of quality. However, if you're writing a system like a banking system or something where you don't have that choice, then there's a different criteria for quality that you need to deliver. And banking system is just one example. I'll take it to an extreme. The pacemakers in people's hearts, the software there better be really good, or the self-driving cars that we're trying to make. So software quality has different ramifications in different environments. And we need to take that into consideration as we're building, as we're considering the criteria for the software and how we're going to test the software. You brought up the comment about different kinds of testing and lots of different testware. With all of these kinds of systems, how do you best test? How do you test firmware effectively to ensure that you can get it out into the environment? What are the right ways to test to get the right kind of feedback as early as possible and make sure that you can get the software out and make it usable in the environment? Question? Comment? Okay, come on. Now my system just totally
You
hung.
might have to
Okay.
float down, and there should be a little kind of grayed out arrow. I notice sometimes in this, my keyboard doesn't work.
Yeah, my screen decided to lock, but I think I got the screen up now. This says modern Z development for a reason, and because I always talk about Z, but it really doesn't matter. And products, you can in many ways just ignore products on the chart as well. The point on the chart really is about how development and how the new modern development practices, and I'm putting it in quotes because this is not so modern anymore. The idea of being able to have this independent development and getting that fast feedback is actually one of the things that should be improving our overall quality. But this says everybody really has to be working together as part of this process. Everybody has to be working together to allow this to flow quickly, because we really want a change that's coming into the system to be able to be deployed into that production environment as quickly as possible. So I can't afford a time delay of people waiting for a queue. And actually, I think in enterprises, this change to not have tickets to get someone else to do something for you. In many places, if we think about deploying containers, we're trying to get around those problems of, if I can deploy a service, a microservice, and it's in a container, I have full control of that. But we still have, and will continue to have, lots of applications that don't necessarily run in those environments. And we need to coordinate all of these systems in a large scale environment. So making sure I don't have those, I've got to go ask someone for database function, or I've got to go ask someone for more system services or a change in the environment, allowing that to be done in an entirely automated fashion through the pipeline allows the improvements of this process as well. Another comment that usually causes a problem with a picture like this, many times I describe everyone becomes a developer. What we have, and the reason everyone becomes a developer, is they're all writing code of some form, or they're writing something that's checked into an SCM that then flows into an environment. And so if everyone is either writing business logic, or they're writing test cases, or writing infrastructure code, if everybody working in the same way, they can collaborate more effectively and work together. So did I cause my problem by saying everybody's a developer, or do I have agreement?
I would agree completely with that statement. It's certainly, you know, when we think about even an SRE now, they're really part of the development team. So yes, everybody is a developer of some
Nobody's
sort.
disagreeing? Nobody's disagreeing this time? I have to admit, I did a panel recently on testing and made that statement, and we went down a long discussion. But I do think it is important, and I think there are a couple of reasons for that importance. One, if we can really have a common way of working and a common way of understanding, then we can deliver better value. If we can work together to collaborate to deliver the value, then we work together better. I spent 10 years in systems management working on the ops side of the world, long before we had this DevOps idea, long before we had the DevOps idea. So I'm in this world, and it's always the developer's problem. It's the developer's fault that something went wrong. It's the developer. And they would always say it's, you know, something else, or it's always the network. You take your choice. You're going to blame the easiest person. Really what you're doing is you're blaming the person that's hardest for them to prove it's not their fault. In the new world, if I can automate all those manual tasks, if I've got a better understanding of the environment, it's easier to understand how the system's running. You don't have that manual problem in the environment that could have been caused to help address the situation. One of the unfortunate stories that I like to tell about why automation really matters, and I can tell the story because it hit the news press, otherwise I never would be able to. There was a financial institution, and I still abstract it a little so they don't get too upset with me, that had a change go into production, and it was a simple code change that they made in production and pushed it. And they all of a sudden couldn't balance any account balance. 0 account balances could be done. But they happened to be in Canada. The Canadian government required them to keep taking money and to keep giving money. And they couldn't have any fees or any fines. It took them less than a week to get back up and running. Imagine running as a bank when you can't figure out people's balances. It was a one line of code, and actually happens to be a comment that was put in the wrong place, that in the end caused that problem by an individual user. That was a change in production. Obviously, it wasn't tested, but we're going to ignore that problem. It was a user who typed something into a file into production. Every time I think about that, and that was long enough ago that you could look it up, but it's pretty old press. If you look at that scenario, you think about that's a really obvious reason why I want to make sure everything's automated. I want to make sure the process flows. And by doing that, I improve quality because I reduce the problems that are happening because of human intervention. Now, you all can imagine what actually happened based on that, how many ever years ago that event was. It is the type of change that led to all of the processes that were put in place to require cabs, to require multiple reviews of items, to make sure that no one who made changes early on could make changes, separation of duties, and all sorts of policies and rules got put into place because of actions like that. The real answer, automating it, was not the first response back when that happened. Now, if we think about the DevOps practices, we can address those kinds of issues and improve our quality overall just by automating out those things that individual users should not be doing anyway. One of the other things that I think drives software quality, and I can cause another problem, is the actual code review stage. The thing no one ever likes, that I have to review someone else's code or I have to have someone else review my code. That phase of code review or collaboration over the code, helping make sure that you have 4 eyes on the code, actually helps improve the code and helps people learn and helps people evolve in understanding the code and deliver better quality. But I do hear many people saying that manual step of code review gets in the way or slows things down. I think it's a positive. I'm
just wondering wondering how code reviews will look in a microservice world.
Well, you're still looking at the code. There's still code there.
Yeah, there's still code, just a much smaller piece, and maybe it can happen faster then, right?
Many times the piece of code you're reviewing is a small change anyway, so it may not be a big piece of code that's reviewing. Sometimes I can remember it was well, in the old days, it was probably a really large change because you do all the coding first, make sure it all works, and then you turn it over to code review. Right? You remember those days?
Big shifts, big blocks of stuff with lots of stuff that could go wrong along the way.
So the smaller chunks really help. The smaller chunks help in testing, and the smaller chunks help in getting the better quality into the small piece. But you brought up microservices. If we think about microservices, that's actually another thing that can cause quality issues if your services are of the wrong size. I actually don't really like the word microservice, because if you get your services too small, then you end up with a bigger spaghetti mess of too many microservices having to call each other in order to deliver something simple. So depending on how you design the system, which you still need to design the system so that you have something that can deliver value without too many unnecessary separate calls. So designing the services in the first place so they're effective and efficient is another way to help improve the overall quality of the system and truly ensure this ability to deploy independently. because one of the big values of microservices should be, I've got independent units. I'm not causing any of the people to argue. This is unusual. If we think about this testing process and we think about the pipeline, one of the other key aspects in testing is test data. And how do you get the right test data? How do you have the right data available to work in an environment? And testing at a unit test level, I need the right test data. That's the error conditions, the boundary conditions. Yeah, boundary conditions. Why do people forget to test boundary conditions? All of that kind of data so I can really test, and then having the right data throughout the process. One of the things I always say is production data is lousy test data because it's good data. By definition, production data is good because it got into the system. It actually made it through the processing, and therefore it's good. It might not be really good, but it's good. It exists. It's in the system. So we want to look at getting our data for early testing, not from production data, but through fabrication methods or through ways of guaranteeing your data that could never get into the system. The one thing I always find a challenge with testing tools is they're really good at validating the data for you. So if the data field is supposed to be alphanumeric, you can put in alpha. If it's supposed to be numeric, the testing tool may stop you from putting non-numeric data into the field to run for your test. In my opinion, the testing tool needs to allow me to do whatever. I should be able to put in the strangest characters in order to cause a problem so that I can ensure I'm actually testing all the error scenarios that could get in to the application. And making an assumption that somebody before you is going to test the data is one of the key critical areas I've seen people cause problems with in their testing because they didn't assume they could get bad data. And all of a sudden the service is now called by someone else and they now have bad data coming into the system and it causes failure or error or problem. Questions? Disagreement? Production data used in test environments? Anyone? Hopefully not. Hopefully there's no production data. When I've looked in one large scale environment that I worked at years ago, and we were working on an application and they were doing a set of testing, I was working with the client and happened to discover in their test data my name, my social security number, my address, my real data. Wow. In the test environment. That was a fun day. That's not something you really want to have happen. So making sure you have cleansed, obfuscated data. Now this was back in the 1980s, I guess, or early 90s when people weren't talking about, well, when we didn't have GDPR and we didn't have some of those other things, but there still was no reason to have my own data show up in a system. So I guess I have an extra concern on that area, but it's not just me. With all the regulations that are around, making sure you've cleansed and masked your data when you have it in test environments, absolutely critical. Anyone else found their own data in a test environment?
Not yet. I guess I could say I'm not looking forward to that day.
Yeah, I don't think it would happen. Well, okay. I hope it wouldn't happen again, but that is a challenge. I like no thank goodness. When we think about the other thing about production data that is a problem when we're considering testing is production data is really good for large scale scalability testing. And I actually think a pre-production environment with production data in it to run large scale testing is a really good idea. But in early stages, why do we need to run 1,000 records that have the same result? What value in our testing? Doesn't that it slows down the testing. It makes it slower to get the results, to see the positive or failure results for no value reason. So we need to make sure that our data, the data we're running through the system, is going to return value. We actually are testing the right things. One of the things that I found in going through environments is a lot of organizations that have started down the automated testing path, they just create more tests. Every time I do something, I create a new test and I put it in the test bucket. And so the test bucket just gets larger and larger and larger without cleaning or without managing the test bucket. And in reading Gary Groover's book, Engineering the Digital Transformation, he actually tells a really good description of how you really need to clean out those tests. And if you have a whole lot of tests that don't necessarily always give you known results, it's really useful to go through and figure out which tests actually do run correctly. One example he gives, take a set of tests, run them 10 times and see if you get the same result every time. Same code, same data. See if you get the same result. I'll bet for many tests you won't, which is the first problem. You should be able to run a test over and over again, resetting the data to get the same result. Once you figure out what tests actually work, then randomize the tests and see if they're dependent on each other. See if you can really randomize that so that you can run them in any order. One of the things I recommend is actually looking at the change that you're making, looking at the tests that are most closely associated with the change and run it in an order so the tests most likely to fail based on the code change you make are the first tests being run. So obviously the unit test on that code, but then the related code to make sure you're getting the feedback as fast as possible. You're getting the failure as soon as possible. Now, later stage tests or tests that are less related to this change are still useful to run because you could have affected them, but they're less likely to be affected. So it is valuable to still run them. It's not saying don't run them. It's just running them later in the test run so that I can get feedback along the way. And if anything goes wrong or majorly wrong, I can stop the test. If things go just somewhat wrong, keep running to know if there's some other, unless it's really corrupted data, see if there's some other problem that you want to find early on, but making sure you can get that full feedback to the developer so they can fix all of the problems while they're fixing the problem in the beginning, but getting that feedback as fast as possible. In order to do that, though, you have to have a well-managed testing set, a well-managed set of tests, and have to have, as the business developers are writing code, the test developers are building up their tests and managing the tests associated with the code change so that you have everything flowing together. One question I get and one question I have is if you are in a world in which you have to translate your code. So if you're somewhere and you have to translate, in IBM, we have to translate all our products. So we have to do language translation, all the error messages, everything have to be translated. So we come up with translation. Translation test is always at the end. Translation test is always after everything else. And in fact, it's usually very near the end of the whole cycle. That means when you're building something, you have this cycle at the end that says, I can't deliver it until I've finished doing all the translation, but I don't really want to translate while I'm going to make changes. So I delay the release in order to get translation done for a certain set of capability. Anybody else run into those kinds of tests that you have to do or you want to do really at the end that end up causing this kind of thing and have come up with another way to solve it? Or does no one else have to worry about translation? Yes, no one else has to worry about translation. How about security scanning? How early do you get scanning done on code for security issues in the process? Is security scanning integrated in the very beginning in the IDE so the developers can get that feedback as they're building the code to say that it's going to meet the security requirements and they don't have any exposures? Or, which I think is the right thing, because the sooner you get that security understanding, just like the sooner I can run my unit test, just sooner that I can get the feedback, the better off I am. It helps in the process. Or scanning my dependencies. If I know the dependency that I'm including has a problem, the sooner in the cycle that I can find that and address that, the better off I am. It'll be more effective and more efficient. I'll be able to deliver the code in the end rather than testing at the end and discovering, now I've got a vulnerability, I've got to go rework it in the entire system. Anyone else have comments? The last area that I really want to delve into is this area of metrics and how metrics really do drive. And I don't know how many on the phone remember Six Sigma on this webinar. I'm seeing some head shakes, so some people do. Six Sigma applied to code. And if you think about Six Sigma, I've got to continuously improve. And if, let's say, your defect rate is somewhere near 2 or 3 in a year, the improvement process would say you'd get to 0 defects. How many people would be willing to sign off on 0 defects in their code? I haven't gotten anybody raising their hand, and I'm just going to assume nobody wants to. One of the things we have to be careful with is how we measure and how we look at measurements. In that story that's actually in the book, it talks about how we had multiple development teams, and they were IBM development teams, and one product team had a defect rate that was much worse than that. And so they could continuously improve. Each release, they could significantly decrease the number of defects, the number of incoming customer reported problems. And in the other case, we didn't have many, so it was really hard to decrease. Well, some of us joked maybe we need to increase the number of defects so then we have a chance to decrease it, but that wasn't the right answer. So you thought about that, and then the metrics were causing a problem because the behavior of the team that had lots of defects, they were positive, they had a wonderful environment because they were seen as doing good things. And the team that had a very low defect rate already was seen as very negative and was not having the best of time because they couldn't improve enough to meet the goals because they started out having too few defects. We're not causing the right behavior. We're not causing the right attitudes. And metrics are what does this in many cases. The culture of the organization and how we see people, how we interact with people, and how we work on things. So making sure we pick metrics that bring out the good value. And I like the happiness metric. That might sound a little weird, but I actually think if there are ways that we can measure the happiness of a team, because teams that are, and I got to be a little careful in the just happiness, you're not going to be happy all day, every day. There are going to be challenges. There are going to be problems. But in overall, teams that are happier, they're continuously learning, they're more positive in nature, do better in what they're building. They build higher quality code because they're more energized, they're more excited. This happiness is really an important metric. Learning is an important metric. If you have a team that's learning and growing and evolving, they're going to build better quality code. Those two metrics don't directly measure quality, but they measure something that's very important that helps drive the quality into the system. And as was discussed earlier, the business value, the customer satisfaction, the NPS. I don't like NPS. NPS drives me nuts. It's hard to get a really good NPS score, but it is a good thing because it's important to understand what people think of your system, how they interact with your system, how they recognize your system. So that will help drive quality into the system. And I think there are actually lots of books that talk about quality. Now, yeah, shameless plug, there's mine. Happy for everyone to read it who has to deal with enterprises and software quality. But there are a lot of others that actually have a lot to do with software quality that you might not think of at first. If we think of project to product, I don't necessarily think that's a software quality book, but the organizational structure, the way you set up your teams, the way you're delivering value, having that team responsible actually improves value. Having that stream aligned team to make sure that they understand the impact of what they're doing. Gary's book in Engineering the Digital Transformation, it really does help understand in enterprises, how can we help improve? And the DORA metrics are another way that we help understand how we're doing overall in our process. And you can't resist the Unicorn Project is just the most fun, well, okay, Phoenix Project and Unicorn Project is fun books to read. But having and learning is the way we do better. So when I think about software quality, one of the things that we try to push is people learning from others, people having conversations, people having the discussion. How do you get better? Are there other books that people think are great and should be added to this list?
I think you mentioned it, the Phoenix Project would go along with the Unicorn Project, right?
Yep. Yeah. I ran out of space on my book, on my thing. I need to slide it over and put the Phoenix.
Oh, okay. Yeah, I saw that. I thought it was weird. It wasn't there.
Yeah. I should slide it over and I put it on. I put the Unicorn Project because it was the newer one, but the Phoenix Project was the first fun, and then the Unicorn Project was second fun. And I have to say, I like reading, so I'm probably a bad example. But I really loved reading those books, and I really hated reading those books because I could feel for certain people in the book, and it was like, oh, that's just too real at times. But yes, they're great reads.
Yeah, I'll definitely be looking at the other ones you mentioned here for sure.
Are there other good suggestions? Anybody have other suggestions to share on improving software quality overall?
There was a book that was written, and this has been written quite some time ago. It's called Microsoft Secrets. And the reason why I bring it up is because it was giving insight into what we would soon become continuous integration and continuous delivery. But I think it's interesting the way they break down how Microsoft was delivering code during that time from beginning to end. And I've always found it to be an interesting read. I picked it up a few years back. I read it when it first came out, and then I read it again a few years back because I think they cover a lot of topics and expose a lot of potential. They exposed the Microsoft warts basically and how they were addressing them, and we all have the same warts. And what you read there is still true.
Yeah, there was actually a number of blogs and postings that they put out with the numbers that they found in their transformation from going from primarily integration testing to primarily unit testing. And when I look at that blog and those metrics, it really helps demonstrate the change in thought process, because they published real numbers on this transformation and how they seriously improve the quality of capability by shifting their focus to the early testing, which is an example of why unit testing in large enterprises and large scale systems can be really helpful, because you find those early problems much sooner. They can be addressed. Other suggestions?
Well, on that note, it is at 1
Yep.
o'clock, so we have ran out of time, and I'm just in being respectful of everybody's time. Rosalind, thank you so very much. I have to say that I'm honored that you ended my my run here as the CDF online meetup host. Thank you so much for bringing up this conversation. I believe that both security and testing will continue to be an important topic in the world of continuous delivery. And everyone who attended, thank you so much. This will be posted up to the CD Foundation's meetup site, probably within the next day. So if you want to share this with any colleagues, you can find it there. And on that, thank you all so much. I'm going to stop recording, and we will see you sometime in January. You'll be getting a notice from somebody from the CD Foundation regarding the schedule for 2022. Thank you.
Thank you. Have a good day.
Thank you.
Take care.
Thank you,
Bye-bye.
everybody, for your time.
Thank you.
Thank you.